All right, so when you are calculating the average atomic mass of a substance, you're going to take the mass of the isotopes, and what you need to do is you need to look at how often each isotope occurs. So if you look at the mass of isotope, we'll call it isotope number 1, says it has a mass of 32.93 AMUs, and then a frequency usually isn't in percent like it is here. So what we do to just avoid mistakes and keep it a little simpler is we will put this percent in this spot, but then we're just going to divide the entire thing by 100 so that it takes care of this issue and this one. Okay, so the problem gives us the mass of each isotope and one frequency. So to get this second frequency, we're going to have to subtract from 100%. So I'll just do that right now. If we take 100% and subtract the 69.1%, then we end up getting 30.9%. Now I want to draw attention to something, and that is the sig figs here. So here, this is 100, and it's not a measured value. It's what's called a defined quantity. So defined quantities have infinite number of sig figs. It is 100 exactly, which means it's 100.00000. It goes on forever. And this 100% is the same thing. It's a defined quantity. So when I report my sig figs here for the 30.9%, I'm just going to look at this value. And really, this is 100.0000000. This is the less precise value. Okay, so hopefully I've done enough explaining now. And really, it's just a matter of plugging everything in. So I've got the frequency of the first one. Well, but I'm going to report it as 69.1%. And you have to pardon my handwriting. This is all with my finger on an iPad. The mass is 62.93 AMUs. And the other frequencies, when we calculated, that's the 30.9%. And that mass, it says on here, is 64.93 AMUs. All over 100. Okay, what I'm going to do now is I'm going to take these values, as messy as they are on here, and I'm going to use my sig fig rule for multiplication and do the same thing over here so that I get subtotals. So the sig fig rules are important here, and they do kind of get in the way. They definitely are a factor. So when I take the 69.1 and I multiply it by the mass, I get a properly rounded number with 3 sig figs of 4350. And then this value over here is going to also have 3 sig figs when I'm done. And so that number ends up getting rounded to 2010, and that's over 100. So when I do the rest of the math, I end up getting 63.6 AMUs. Okay, so what you look at is, remember, in terms of sig figs, this is a defined quantity, and when I add these together, I end up getting I end up rounding to 6,360 because I can only give my answer to the tens place. And so at that point, then, when you divide by a defined quantity, your answer will only have 3 sig figs. Okay, so that's that one. And hopefully that makes sense to you. But, you know, another thing to do to kind of double check is, does the value of 63.6, does this make sense? So if you look at these two masses of 63 and 64, which one's the more common? This one. And this value here is closer to this value, and that makes sense since this is the isotope with the higher frequency.